So hello guys, today we are going to solve this problem. So I had attempted this problem in the previous stream today only, but this I could not solve it because of time constraint. This will be another shot at the same, and this is an unseen attempt again. In the previous video we discussed like we were not able to form the logic of LIS, LCS, but here in this video we will be actually, like, I studied LCS in that stream only. In this video, I'll be explaining LCS, and then we need to check if that can be applicable in this one or not. So there is no guarantee that the exact same thing can be applied here. But first we will do LCS, then we go ahead with whatever is next. How to solve this problem. Right? Without any further ado, let me jump to the screen over here. I want to do one thing, just give me some seconds. Give me a few seconds, I'll be able to set my PC up. Yeah, let me just change the theme to light mode. Makes sense. I don't like the dark one for some reason, I don't know why. Yeah, for this note editor. Okay, let me just a second, guys. Let me just plug in my charger to the smartwatch. Okay. And I have to finally plug it into the desktop. Okay, just a second. There we go. Mm-hmm. Cool. Now let's jump to the screen. First, I need to explain the problem. What problem is required and why we are. Uh, I have to copy this. It is. It contains everything. Let me undo this change first of all. I have to copy this image. Let me erase it all because that is of no use. Cool. Okay. Okay, so the problem is about, quickly I'll tell you the problem statement which I have already studied. Alright, so the problem is about, yeah, the problem is about there are two strings str1 and str2. You have to return a string, answer string, or whatever string is, which will contain string 1 and string 2 as subsequences. That's the thing. So this is kind of the super subsequence which includes both of these. Correct? And here what I want to say about the answer is that, so basically we all know what a subsequence is. So maybe this answer is a very long string, but the elements of str1, let's say it has a, b, c, f, right? So all of these should be there. A, B, C, F should be there. and there can be many characters in between in this string, but this entire thing should exist in this particular string. Make sense? And here string 2 will be something like fgh. Then fgh should also exist irrespective of its position in the answer string. They should appear sequentially the way they appear in this str2. So our goal is to return a subsequence which has both of these. So the straightforward is like just you add str1 plus str2. It's a good approach because obviously it's the right answer. This string 1 is in subsequence, string 2 is in subsequence. That's what we need. But this is not the smallest one. So we need to find shortest common subsequence. Supersequence. So I think this is clear to you. In the previous session, let me just delete this. Right. So in the previous session, I had came up with this approach. Yeah, this approach of there is a string 1, there is string 2. So I have come up with this approach that string 2 had some elements, string 1 has some elements, string 2 has some elements. So I have come with this approach like what is the common subsequence in both of these, right? So basically there might be a case that these guys exist in this particular string and it has the length 3. So what is the longest subsequence of this string that is there in the subsequence form in this particular string, or vice versa, the longest subsequence of string 2 that is there in string 1 as a subsequence. If we get that, so basically what we can do is the values which are left, we can follow this order. The values which are left should be placed in the string 2. Like this one is not there in the shaded area, it means it is not there in the final string. So I propose an answer string which is basically first copy str2. You see these elements are already there. So what we are going to do is basically str2 is sorted, we have str2 with us. Now we're going to chip in these values at their respective places. So this can chipped in at this place, this can chipped in at this location, and these guys are already there. So basically this chip in thing we can do it in some sort of steps. If we note down the indices where there is a match in both of these, if we kind of mark it, the ones which are there which are not marked can be chipped in wherever the location allows, right? Yeah, so we can do that, we can definitely do that. So basically that is the case, and to be honest there can be multiple such markers available. Instead of markers we can also use substrings as layman terms, like the exact substring we kind of extract out. Let's say the common three elements are a, f, e. So we can then do the processing later on and like combine this chip in step can be performed. But the core thing is the main quest is to find the longest common subsequence. This is the main quest and we'll focus on this only. So first I will be teaching what LCS is, and then we can think how that can be applied to our case. So this is an LCS tutorial. So I revised LCS. I was not able to do it in the previous stream because I did not know the exact setup of LCS. I forgot. In this video, I'll be making sure that I'll teach you guys how it actually works. So I have to take an example. Let's say I take the example like this: A, D, D, C, F, E. And another example, we get G, F, E, A, C, F, and T, T, E. Right, so this is str1, this is str2. Examples are quite big actually. So the dp, so the problem constraint was that we have to solve this entire thing is in an order n square at the worst case. So I was able to propose an order n cube solution with my settings, but that was not the right thing. Basically that was not the thing which we needed. So this is the dp guy. You see, this is the dp which I have created, and it will accept two values. What I was doing it was actually wrong, but this is the kind of framework for LCS. We all should remember this, that we will start from the end indices of each. So m and n, this is, let's say, mth index, this is nth index, so we'll start from dpmn. What does this mean? The meaning of dp is very important. By that, the meaning of dp should be independent problem in itself, so that we can aggregate it or we can recompute it without any hurdles. So this means what? M to n means what? Let's say this m is somewhere here actually, and this n is somewhere here. Let's choose this f guy so that we cannot generalize it. It cannot be so specific like CC should match. Okay, so what does this mean? That this is mth index before this and before this. It is a separate problem now. The answer of this problem, the problem is this, from 0 to m minus 1, m actually 0 to m in S1 and 0 to n in S2. Find LCS. Whatever LCS you get in this region. And then what you can do is basically you can combine. We can take the maximum length one and basically just move on, right? The one path which gives you the maximum thing. So there were multiple checks. First thing first, there was an if statement which says that if mth element is equal to nth element, which means if these two guys are equal. What does that mean? It means that this can be a part of subsequence, because obviously E has matched. Now we look if F is there, here it is F, and F equivalent is over here. So that's the case, right? Otherwise, if we cannot find it, then we have two options, whether to take it or to drop it. I'll come to that, right? So this is the case. So in this case, it is yes. So what we'll do, we will do this E plus dp of m minus 1, and n minus 1 is the answer for this state, this particular state, this mn state. The answer is that E plus dp, whatever you get from this part and this part independently. Make sense? Now if we come to the next thing, now we check m minus 1th element is equal to n minus 1th element. If we check this, then there can be two possibilities, yes and no. So for yes, we know that go ahead and do this. For no, what we can do in this case is basically what they suggested. The common LIS problem solving, it suggested that Since these are not matching to each other, we have to move either of these pointers to the left, ignoring dropping this guy. So we can drop this guy, or we can drop this guy as well. There are two cases, right? So यहाँ से there are two cases. One is drop m minus 1, and here it is drop n minus 1. So this considers the both cases, and then you do the same thing, and at the end you will be there at the this very position and this very position, hopefully. Obviously might be the case like some elements are not there in the part of the thing. Now the answers which we get from this can be strings, or it can be some numbers, right? If I maintain a string, what will it do? I can maintain a string. Basically, if we found that if E and E match, so I can create a string at the moment. So string was earlier empty, and I can append E to it and then move to the next stages. Right, so whatever we get from this guys, we just add it to this guy. Now this addition could go crazily enough. So how is DP applicable in this case is that because of the things which we are going to do. So if it was not a match, what we had done, we had two options, right? We can go with this F, we can go with this T. Right, so that takes us to the next stages. So one stage will be like this. Wait, let me just show you. So if they don't match, these two guys don't match. So what I can do, one step what I can do is basically I can move to this part and this whole part. And what I can do next is basically other way around is this. I can do this whole part and I can ignore this part. So you see this number and this number, these are forming pairs. आगे जाके what can happen is that this number will come up again. It will form pairs with this guy as well. So this is order n. It is basically unique. The uniqueness is determined by these two indices. However, I feel the chances of recomputation for which we use memoization is low or good. I have to be sure on that. I'm not getting an idea about that basically. So what I'm saying is, let's say these two didn't match. We'll focus on two cases. First case is this, ignore this guy. Other case is ignore this guy and focus on these cases. So what happens here, if you go this route, it will be like m and n minus 1. Here it would be m minus 1 and n. So in future this can go to n minus 1 for sure, it is possible. And this m minus 1 can be still there. This is m minus 1. So m minus 1 and n minus 1 can still get formed. Or if we go ahead and compute this guy, there might be the cases that multiple such instances are already computed. So in that case, we can just use dp to make it simpler. Fine, I got the idea of dp. Now, the thing is that in our problem, we have to work with the string values, right? But this works only for numbers. Basically, this returns, if this will return a string, then at the final step, we have to do this addition, which can go up to order of n. That's not affordable. Rather, we can use temporary data structures. So what can we do with there is this. Basically, we go ahead and instead of maintaining numbers, what we can do is we can start with strings only. So let's say e was common to it. So we had an empty string at the beginning because we have no common part. Now if we have e there, so we push e to it and move to the next recursive stages. And then whatever comes there, we push it. If there was no match, there are two possibilities. First, whatever we have in that string, keep it. The upcoming element, since we are dropping it, so we will be taking another guy, or let's do the insertion at that level, right? So we go with the previous guys and then we kind of chip that in. And while retreating, basically after putting our steps back, what we can do is basically pop that off. So whenever we reach a result kind of stage, we can report the strings. That looks good to me. So guys, now I'm jumping to the code straight away because I have already spent a lot of time in this. I wanna wrap this very as quickly as possible. And trust me, I haven't seen the solution afterwards. Okay. By the way, guys, Samsung watches really suck because they show that the battery is very less efficient. Number one, I'll just check if we have. Well, by the way, guys, my feed is very much random. I don't know this guy very well. I know him, but I hate him. Okay. So there, the battery is very less efficient. Number one, I'll just check if we have. Well, by the way, guys, my feed is very much random. Ha ha ha. Okay, this is the thing. Now we need to apply things. Cool. First thing first, what are the data structures that we are gonna need? We need, first of all, we need m, which is str1.size. Then we need n, which is str2.size. And then we have something like string. Yes, this is not the answer string, ladies and gentlemen. This is basically for the recursion thing. I'll keep track of the max string which we get. Then we have max string, which is again initially 0. Now, what we need to do in this case, we'll start with, sorry, recursion will start with m-1 and n-1, the ends of the both the strings. We pass str1, str2, and then we pass this s, and then we pass this mx. Also, we have to pass these m's and n's. We run this, and then we get ms as the max string. Okay. So we got this right, and then as we noticed elements of max in these strings, what can we do? Okay, that's a separate thought. I think I have the plans because what I'll do is basically max string is common in both of these, right? So for each of these, what I'll do, I'll prepare an answer string answer which is empty, and then each element of the string 1, I'll check if that is there in the max string. If it's there, then better like, yeah, I will remove it from the max as well. Right, got it. But there is some sort of sequence which they follow. We will think about that later. First, let's get the max string figured out. The way we also need dp, correct? For that, I'll create vector of int dp, and it could be of level m comma n, right? अपनी शामों में हिस्सा ना किसी को ही दिया, right? So this is the dp with us, and then we have to do this. I'll go and create. Before that, we need to pass this dp thing to this guy. Mx is a string, and here we get the dp. We have to assign these folks to -1. Right, here we go. Now we have this void recursion. We have integer I, integer j, string ampersand. Where is the ampersand? str1, string ampersand str2. We have string ampersand s, and then we have string ampersand max, and then we have vector of int ampersand dp, integer m and integer n. Now the most important thing, if I equals to 0 or j equals to 0, what we have to do in this case, in both of these cases we have to quit our quest. So here we just return. Okay, 0 means like both of them, one of these are zeros, so we can still go one step there, because 0 is a valid index the way which I am operating with, correct? So I can say that this is, if this is -1, okay. Next thing is about pushing the character. If the character is there and it matches, then we have to push it. So if str1 ka I, and which is, if it is equal to str2 ka j, then in this case we need to do something, and here else statement we will be doing something else. So what we'll be doing, if you should see this, so if it is a yes, if it is equal, we have to append e to the s, and we have to go to this state, right? So if it is equal, first thing first, what we do is basically append the append character in temporary string which I'm storing. So what we can do here is basically we can do this s dot push back or push front. I need to think on this. It can be push front. Push back will also work, because I'll reverse it at the end. At the end I'll reverse it. I'll reverse mx, boys. Reverse mx. Now append the character in s, we can do like this. Then we go to next stage, which is recursion of I minus 1 comma j minus 1. And then we go to str1 str2 s mx dp m This is the next step, and if s dot size is greater than mx dot size, that's what we have to do. Mx equals to s. That's what we have to do here. And at the end, what we will do is s dot pop back. Right, this is what we need to do here in this case. And in the else loop, what we will do in this case is this is basically where there are no matches. We have to keep s as it is. What we need to do in this case, we have to go with two stages. And after each stage, we have to check like what happened with this guy. Okay, so we are doing some changes with s, right? And after that, yeah, that is fine. That will be taken care of. So there are two stages. First is recursion of I and j minus 1. I should copy this part. This is this kind of static. ओ चन्ना मेरे आ चन्ना मेरे आ चन्ना मेरे आ बेलिया महफिल में तेरी हम ना रहे जो गम तो नहीं है. Am I singing? मेरे आ चन्ना मेरे आ बेलिया. Sorry guys, I had no idea. Okay, so this is recursion 1, recursion 2, and we have to just do this because the rest other things will happen at this point. And there we go. This will return us a particular string which is the good string, correct? So for the testing purposes, I would like to check if the recursion code is correct or not. For this part, I'll print this guy, and let's see if it is working or not. We can also fix the errors which we see over here. There's some error at this point. What is the error? Non-void function does not return a value. Okay, I have to return some values as well. So why not return mx? It will be a wrong answer. Agreed. But I want to see what's the case. For CAB and ABAC, it is coming out to be BA, which is actually AB, correct? So here it is coming out to be this guy, which is exactly same. Yeah, it is same. That makes me happy because BA we have to reverse the MX string. Yeah, so we got the MX. Yeah, first we reverse it. Reverse is a inbuilt algorithm where we have to just pass the iterators of begin and end of a particular data structure. Cool. Right, this is cool. Now I have to form the answer string using mx. So this is another logic which I will be showing you in the iPad. Right, so let's get ready for that. So what the problem statement now is, the problem statement now is we have str1 with us, some folks there, and we have str2 with us, some folks there as well. And we have found the common apples, which exist something like this. And we have these apples listed like this. Yeah, apples are red, maybe I should use red. Let's replace apples at the first place with berries. Okay, so we have these folks here. Now we have this string with us. This is the mx string. From this we have to chip in these values at appropriate places, right? So what I'll do for this particular thing, I'll go ahead in this particular string and find the first occurrence of it. Sure we can. And whatever comes before that, we just append it at this location. Whatever part that comes before this, we append it at this location. Now, strings are like vectors. We cannot do insertions at some certain points. That's fair enough. So what we can do is, whenever we notice this kind of structure, so we already have an answer string which is empty. So what we will do, we will inject this to answer. We just add this to answer string, and then we add this blue dot, blue apple. Okay, then we add this particular guy as well. So answer is now containing this. Next we go for this guy, and what we do here, or we can do this as well. So we go for this guy in this string as well. We find whatever is there in this part and we add that as well. So this is S1's container, this is S2's container, and then we add this guy. Makes sense? This guy is sorted. Then comes this guy. For this guy also, we go ahead here and we also have to note where we have traversed in that part. So here we are at this point. Okay, that is also an important step. Basically the ends. Here we need some ends defined with us. Okay, it's fine if we keep the pointer at this place. What we can do is basically we check where this pointer goes, and as the pointer goes to this location, whatever we get across that path, we keep pushing over there. The pointer will stop when we are just before this. I think my battery is down. So I think I have figured the approach out. Let me just write it in detail so we don't waste much time in coding. Okay, it's better to use the example in the test case. ABAC and CAB, right? And bar was the MX. So ABAC and CAB. Here I'll remove this guy. I'll use a red color. And bar was there, which will be reversed to AB. Cool. Now let's work with A. So our pointer started with this location. Actually this location, -1th index. This is pointer to P1, P2, which started with this index. Don't get confused with pointer, these are not actual pointers, I'm just using it as a term for navigators. They're just iterators, okay? So P1 is there and P2 is there, right? So P1, P2, correct? They start with this. First we start with this A. We send a lookout notice for A and we start looking out for A in this location, in this direction. The moment we spot A, before that, if there were more characters like C here, what we could have done, we came to this, we check this is not A. So what we will do, we will push that to the answer guy. So the answer guy has C now. The moment we spot an A, we stop and update our pointer to this location. This is done, sorted. Same thing we do here as well. So here we didn't found anything. C was not there, so we just came to A and stopped over there. So what we did here in this case we found an element which is C, which is not A. So we pushed C to the answer, and then our pointer is over there. There's a problem with my Samsung watch. Cannot charge. Watch needs to cool down. Okay, I removed the charger. Alright, guys. So, yeah, it is heated up basically. Yeah, that was an important interruption. Sorry for this. This is a chill stream, okay? So you should also not be in a fast pace mode, right? So basically here, see this. This is a serious problem solving, to be honest. So I'm just focusing on the problem. Yeah. So there is A and there is, oh, okay, so we pushed C over here. C is here, right? The pointer comes to this place. This is P2's place. Now A is sorted, so we just add A over here. Now we come to B, and for B, we send a lookout notice from P1. Oh, we found this at the very next place. So the P1 is here now. So what we did was just, we did nothing, we did not add anything. And here we look for B, but we got A. So we look for B in this direction. So we found B at the very first place. So that is where we just, I have some fear that this can go wrong as well. Let me discuss it with you. So in this case, it is fine. Like B was for A, P2 was not here, P2 was actually here. And what we did in this case is basically what I did was I just moved my pointer to some extra place, which is there. It is at A. Now we move to the next step. We see B is matching with this, so we don't add anything to the answer string, we just add B at the end. Cool. Now whatever's left we just append it, A and C. So yeah, the thing which I was afraid of is this basically. If there are, let me think it. I think this will do the job. Like I was thinking of this part, man. Like see this. I think that is already covered. I was thinking of this part. Let's say there is A B A C, and here we have B C, and but here out of many characters, I was just thinking like some characters which are here, if they're common in this one as well. But if they're common, they will already be in the MX string, so they will be taken care of. So yeah, I think this is the approach. So guys, the thing is that you should notice this if you're a beginner. First, you formulate your approach on paper. It's very easy to translate it into the code. This is a thumb rule. Because if you start thinking while you're coding, that is fine, you should do it. But it takes time. So here I have not figured everything out, but I have figured these headers with which I can move ahead in coding and I can think the required stuff very quickly. But if you're not aware of P1 and P2 and you start thinking like how I will implement it, this kind of picture is very difficult to create, to be honest, in your mind. You need training and you need basically to think at higher order, which comes with practice. Cool. So first draw everything on paper and then go ahead and start coding it right away. Cool. So we have the MX string with us. We have reversed it. Now It's the time. For what? It's the time when we use this to create our answer string. Cool. So I created our answer string here. And what else we need? We need pointer 1, which is initially at -1, and pointer 2, which is also initially at -1. Now what I need to do, I need to go for each and every character in the mx string. So that character is s. Now we go with this while, yeah, while wait, what should we do? While p1 is less than m, if the first thing we do is moving the pointer p1 plus plus. If, okay, so there can be issues like p1 plus the next element there is I think it's fine, we can apply that condition over here. If p1, we start moving in the forward direction, we do p1 plus plus at the first place, then we compare that with some value. Okay, so if p1 plus 1 is less than m, and then string str1 p1 is equal to x, this means it's a match. What we do, we don't need to do anything. If it is not equal to x, in that case what we need to do, we need to append that particular, oh, not append, basically if we push, we should push ideally. Appending is basically order n, probably, I'm not sure, but there is some catch with that. So this is pushback here, answer.pushback, what we will push back. So the thing which we are going to push back is basically the str1's p1, or simply, yeah, that's the thing that we need to push, and rest all should be taken care of automatically, else we have to break out of this loop. Same goes with P2. I'll be careful here because previously I have copied code, similar code, and I forgot some changes. So P2, and this will be n. If P2 is less than n, we will move P2 ahead, and P2 plus 1 is less than n. Then this is for str2, this is for P2, x is same, answer is same, str2 is needed, and P2 is needed. And then else we break, cool, fine. And then we have this little adjustment, and at the end what we do is basically this. With these steps we do this. Now this is the next step. Here we start with this is basically answer dot pushback str1's I just copy similar things for str2. This will be n, and this will be p2. So I hope it is the correct answer. Let's see. Okay, there is some problem. The answer is CABAC, but there are some extra appenditures. Okay, if it ends at this place, right, else one. If there is a match, if there is an else statement, it means it has a match, right? In that case, what we have to do is to increment the guy, or we have not to increment the guy. We need to increment the guy if we are at the end position of mx, or we have to change our approach. Basically, we start with 0 ones. Yeah, this has to be done. We start with the 0th indices, and then we have to do this at the end. So what we did was we just checked it. Okay, so we have to check for P1 first, and then we have to essentially check if it is equal. P1 is not equal, then it means we have to push that guy to the answer, and after pushing it, we have to just do a P1 plus plus, and else if they're equal to each other, in that case, just skip it. So it will be just P1 plus plus. Does that make sense to me? Quickly do the same changes here. P2 plus plus, and apart from that we also break up. You see, that's how we solve this. This is accurate now, but there can be some weird cases where it can fail. The craziest thing for me was this, man. This I had in my mind that I'll face similar kind of issues, but still we have not cached the response, which I forgot basically. So we are doing some sort of caching here, right? But in my approach, there is no caching. I forgot how I use caching here. We have to use the memoization thing, right? So this recursive code has to be converted to the memoized code, because this will go to the next stage. To be honest, next stage is, and it will do some sort of mathematics and stuff. And if it goes to next stages, probably there's one case here, like it will be appending the character s. It will be then going over there. I think it has nothing to do with s, because exploration of s will be done anyway. Let me think, man, let me think. First of all, this has to be a integer. Sadly, it has to be an integer. We will return 0 as the answer. Let's do a check if dp of ij is not equal to -1. This is there. Then there is one more thing which we need to do at this place is the going to the next stage. What we have to take care is the uh, here is this is the actually this is the answer. Say this as empty, so answer equals to 1 plus this part, and here we just do this return answer dp of I and dp of j equals to answer. We have to return this. We got to return that, and here we have these two answers. I'm afraid that this might get compromised, but that is also not possible because we will eventually go ahead, drill down and down to reach the state where we actually create the maximum streak, right? That state will eventually come up. Okay, so let's submit it and hope it is passing the constraints. There is some error here. Steady out is good for us. So it says that 4 B's, 5 B's are common, right? 3, 4, 5, correct. 5 B's are common and the A is common. And here it says that, so what it did was it added an extra A. This is something which is problem at the, so the mx string is correct, which is correct. There's no problem in that. So this particular thing is correct for this case. The problem is there in this part. So we started with this pointer. We found out that okay, this b is tackled down now. So we added one b for that. Then we come to this b. We found out one a. So we just added one a here and two a's from here. That makes three a's. This was the thing I was worried. And you see, like this a and these two a's, they have to be added, added, right? So I added one a and I added two a's, which became three a's. But if we had only two a's here, it will just do the justice. So we can have this a in our hands, we can have these two a's in our hands, and we come up with something which is AA. This will not work. How can that be tackled? We need to create some data structure. So let's say we got frequency of A as 1 in this and 2 in this. So I'll do this that A has, I'll take the max of these two, which is 2, and I push 8 twice. So okay, let's do that. This is a frequency map. There has to be one more thing over there. Here we will be modifying the maps as well. So we need to use somewhat like iterators. We go with the larger map. Instead of maps, what can we do next? If we cannot use maps, then so yeah, here I can do that. Basically, we have to go somewhat like iterators way. Okay. How can I do this? The ones which are not found in one should be taken care in the another one. So we'll take care of that. Yes, so I got that. Yeah, that just I got. Today is Saturday. I cannot cut my nails. They're pretty big. Okay, so here is this thing which I figured out. So I'll go to this FM1. I should use something else here. There has to be an order as well. No. So it is ABAC. So we need to get this guy CPAC. So what went wrong here? The cute little bug which I do every time. It handles this case. I cannot wait to submit this because this is hell too long. Okay, it was able to figure out BAP is a common thing. BAB. BAP, which is here. The moment it finds it, it breaks. Right, so what we did here, the difference is that it has this guy BC. Yep, so we start with B. B is there in line. Then we start with, we come to this pointer and this pointer here. Then we start with A and we push CB over there. This is one of the suggestions. Let me just go by my logic only. So we are at A, so it pushed C and B together, correct? Now A is matched over here, so we stop in this one, and here also A is matched, so we stop at this guy. We actually come to this pointer now. C here and B here, and the next is B. So B is there, and CB के बाद basically after CB we pushed A here. CB is good. Now for B we found out that B is there already, and we'll push it anyway. For here we found that for B we have to add CAAA. That's where it is failing, right? Let me do it manually in my screen. Please reactivate. Okay, it is paused. I need to connect again. Wait a second. Okay, the example is this BCACAA. It is BCACAAP, and then we have BPABACCC. BAB as our red apples. So for B we are doing things. We found out Ptr1 to be here, P2 to be here. So booyah, this is a match. So this moves to this point, this moves to this point, and we have add a B to the answer. Then comes this cute little A. We found that these guys are different foreigners. So we add C and then we add B, and we move this to here. It is A and it is good enough. So we move to this guy and stop. Here similarly here we found A, it is good, and we move to this guy. So here we added A over there. Now the next apple is B. So for this string we find out oh B is there only, so we just move to this apple or this clause, this space. Here we saw that okay, we are not getting B, we're getting B at this point, and this is currently C. So what we did was we added C and then we added these many A's, and then we add then we come to this place here. Now these match, then we add the B, and then we have pretty much triple C which is left. Oh, okay, so we were here, right? So we add A triple C. So this comes to be BCBA, BCBA, C triple A, BACCC. This this is quite huge, to be honest. If the length matches, it might be a case. Right, so if I count the length, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Here it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. What's the difference? There is A triple C, which is good. There is B as well. This part is doomed. It was C triple A, BCB is C triple A, but here it is appended as triple AC. So what is that? C triple A. C triple A, right? So we are at it as triple AC. Okay, let me just do one thing here. For the sake of the checking answers, I'll do this. And here I'll tweak this. Just see. Let's run it up. Yeah, C triple A thing was good, but it was coming out to be triple AC. Problem is actually at this level, man. My above logic is clear cut same. What went wrong in this approach, the map approach which I'm using? Let me just do a clear presentation first of all. I'll go back. I'll go back and back to the starting point, and there I'll do some changes which will be very much following the logic which we created. Cool. So for this B, I use this color. So this is the B, this is the B. So we pushed nothing into the map. Then for this A, I'll use some color like this. So this is found over here, this is found over here. So we pushed this guy and this guy in the map, frequency map. Then I use this red color for this guy B. So we got B here and here. And then we pushed this guy and this guy to the map. Right? This has happened. No, pardon me. There is no such thing. So it is appended probably at the end. Use some other color. I believe these two look same, so I should erase this. Such as this is fine. Then we have to erase this as well. I'll use some color like this. So what happened in our case? We pushed nothing here. We first the result of this. Let me use some other color which is entirely different, like this. So the result of this come out to be B. Result of this pushed BC. Actually, it can push BC, but we are doing it from the map 1. So it pushed CB. And this was A only. This was C triple A, which has to be pushed. And it was pushed as triple AC. Now that's a problem because this sequence has to be preserved. Get my point? That's the problem, right? That is the problem where we are stuck. So that entire approach fails where we kind of do that kind of insertion. So the new problem is this, that we have this cute little substring and we have the another substring which can be there or which cannot be there. At this level as well, there can be some common stuff. At this level as well, man, we have to solve the same problem. So I did LCS. I thought like I can find the places where I can chip things in and just include them blindly in the remaining spaces in the other one, but that's not good. We can do this, by the way, if it is longer. We count frequency of these folks in a manner that we take the longer guy, first one over there. This is exact same problem. This is a sub problem actually. Oh man. This is the same problem where I got stuck, right? How should I get out of this? So what I did was I found out the longest common subsequence, right? I found out that. I am good with that. I actually found out length of it and I actually found out the exact subsequence which is the best one. Then what I have to do is to basically the remaining ones, this area, this area, this area and this area. So in these two guys, whatever is there, that is a separate problem. There is a separate answer for it. Oh, this is the two partitions. In those partitions, there are some operations which has to be done. So guys, I give up now. Basically, this is problem in problem thing. That's what makes it hard. You solve it using LCS, but you actually didn't solve it. You just found out LCS, and then the next problem was actually working on LCSs you get. Can you get all LCS? So the way we have defined DP for this might not work. So we have to think DP in some other way. Like let's say we have this guy. If you want to reduce the problem, how can we do that? So I was thinking that the answer of this, so basically these two portions, they can be combined to form a string. Now this guy is the foreign one. This is an independent problem. We solved it and we found this particular string is there. Now there are this, let's say there's many folks which are standing at this place, and here it is this one guy. Now if we have to incorporate that, so this is absolutely fine. This is using it. This has to be appended here, and also this has to be appended over there. So if we are talking about these two things, so if we find what is common in them, so let's say we find this part and this part is common in them, so we put one of them to the answer string. in a sequence only. So we put one of the guy in the answer string. Then we come to the next one. If there's no other element, there's no match in this, we just put, right, this is also a way, man, to solve this problem. Basically here, let me show you the problem which was there with this BCAC triple AB, BCAC triple AB, and BBAB A triple C. I will create a copy of it in order to use it frequently, and I'll keep it small. Fine. Okay. So what I'm saying is, let's say we start with these two folks. So we come up with something called BC. Now we have this A and C. So this part is there. So if we sort out AC, we get something like, since BC is already there, we have to introduce AC. There are two C's. So this will be ACBC. And then we have other guys here, which is AC. So it will be like AC, ACBC. Here it will be like two ACs, and here we have AA, which will be just one A. This will be like CB, which will be a CB is fine. Then we have A, then we have CB, 3, 3, 6, 3, 9, 4, 13. This is a solution, but is it a good solution? This is BCAC, this one, BCAC is there, BCAC triple A, triple A, B is there, and BBAB A triple C, BBAB A triple C is also there, and this is in fact 14 2. I have a problem कहाँ हो सकती है? We are starting with this guys. Problem क्या हो सकती है पता है? पता है मुझे. This can start actually here, not here. So let's say this part is not this big. It's just it is just AC. In that case, what we will do? We will make a BC here, and then we make a A here. So we created ABC, and then we go ahead and add these folks out of this, which is clearly a wrong approach, to be honest. This AC was already there. That approach also did not work. We can find LCS, longest common subsequence, or through strings. It gets smaller and smaller and smaller. And at the end, we got some folks. So basically in LCS, where we were rejecting some folks, like if they were not matching, we just rejected them. Instead of that, what we can do is if we add those folks, then it will not make any difference, man. Let's say D matches and A and C doesn't match. D matches, A and C doesn't match. Guys, I'm done on this problem to be honest, and I cannot solve it. Yes, it is a setback, and I have to learn from the solution which is there. I spent quite some time here. So they are using LCS. There's an editorial given, right? Sorry guys, sorry to make you disappointed. I don't think any of you sees these videos. But yeah, I'm going with the solution for this one. We are given two strings, str1 and str2. This is the solution. We know LCS. A strong understanding of LCS allows us to efficiently construct the SCS. If this concept is unfamiliar, to first solve the following problems. Note the LCS represents the longest sequence of characters that appear in both strings in the same order. To form SCS, we preserve the LCS while inserting the remaining characters from both strings around it. We preserve LCS and we insert remaining characters from both strings around it. That's what my approach is. So actually I'm at the right approach. So why not I fix my approach only if if I know that that is the case. If we have pointers where we have to put, okay, so sorry guys, I basically forgot the core agenda of my planning, which was basically, yeah, let me just copy this. I'll paste it here, I'll paste it here as well. Change the color of it. Okay, so basic agenda was my point was that we have these cute little pointers which are guaranteeing me that this is the BAB. This is where our final string will be. They guarantee us. So we have this BAB ready with us. Inside these portions, they have to fit in at any cost. Inside this portion, they have to fit in at any cost. Right? Okay, so inside this portion, this has to fit in. Inside this portion, this has to fit in, and this has to fit in here. That's the fact. Right, so it is guaranteed that C and B will reside here. It is guaranteed that A will reside here. Now, if there is A already here, we have to insert A and ABA, something like this. So in that case, what we can do at the best level is this. We can insert B at this place, if it is possible. But how will that come out of the discussion, the flow which we have decided? They have to be compressed, right? So this isn't it a simple problem, similar problem, that this string and this string we have to merge them. To make another cute little. So this is also a problem too, which is the same problem, right? So if we run our resources into this, if we run our computation into it, this will basically cost us order n square again at each point, and there can be like n such checkpoints. We can have these two strings with us. Yeah, we can have these. Correct, that is correct. We can have that. And then the gaps of it. So yeah, I think I'm just fooling around to go with the solution. Approach 1, backtracking. This is really, this is the recursion approach. Shortest common super sequence. Okay, so yeah, it is doing working at that level, man. It is finding shortest common super sequence. Super sequence, shortest common super sequence. Yeah, this they are calculating the answer at the first place, and they have just memorized it, and that is it. That is the solution. I actually went to merging that to basically chipping in thing, which lead me to a different direction. I should not have done that. Yeah, so they also say that inserting remaining characters around it. But the core thing lies here. If the both strings are empty on this, if any one of them is empty, return string 2. If other string is returned here, then if the character match, include it in the super sequence. If they don't match, try those options. So this also is coming to my mind. They take one guy and then take. Let me do this. Let me understand this. What's it actually working? So they are actually returning strings as DP, which I thought is a bad idea because the length of the string is like this. Oh man, the order of complexity is after memorization it becomes it still becomes, yeah, it still becomes n cube. Then we have this approach which is exactly this is n cube, and this is again, this is order n into m. Really, are you crazy? This is the solution, man. Because we all know that the sizes are of the order 10 to the power cube. And at the first place, I was already there with such a solution. Yeah, with the DPs which I had constructed, I was there. I was able to, yeah, I was able to think in a similar way. To be very honest, I was able to think in a similar way they have done here. This is some sort of another kind of optimal solution, man. Now they're playing with strings. This is what space optimized dynamic programming. We'll read the code. So this is a string 1, string 2, this is the vector. Here dp is 0 initially. This is the initialization of dp, correct? Okay, call is what? This is the length. This is an integer vector dp, correct? This is a length, and they say that the length of is this one. Then we fill the dp table. If characters do not match, take the minimum length option plus 1. Because actually I need to study this very hard. and then I can actually do that. I have to look for better solutions. I think people have explained it in some sort of manner, right? This guy has very good upvotes. Why are these many languages? He has given it. That doesn't matter. Can you please upvote? Please upvote. I will do, bro. When I first saw this problem, I realized that we need to find a string that contains both. But that's inefficient. Correct. A better approach would be to find the common parts between two strings and avoid duplicating them. Common parts you can find. First, I find the LCS of two strings using dynamic programming. And then I construct the shortest common supersequence by starting from the end of the both strings and working backwards. So both strings K and C. And okay, so it worked on that string. If the characters match, I include it only once. If they differ, I include characters from both strings. If they differ, I include characters from both strings. If they match, he included it only once. Cool. If they differ, I include characters from both strings, correct? Finally, I add any remaining characters from either string. Reverse it to get the answer. Build a DB table to find the LCS. Trace back through the table to build the super sequence. Okay, there's something. They're using DP table approach of LCS, which I did not follow, but they use LCS in that way. I'm unaware of that DP table approach, to be honest. This is basically taking me to read this problem. This is hell customized, man. Okay, backtracking से समझना पड़ेगा. N be the size of str1 and m be the size of str2. Here, a memory limit exceeds, not the time limit. I both exceed. So guys, this stream is very much longer today. If I just refresh it, it exceeds, not the time limit. I both exceed. I think I have still half hour to this problem, so I can read the solution and understand it. Okay, so what happens in approach 2? Let's read it. The issue with backtracking approach is that it repeatedly computes results for the same subproblems. Correct. To optimize this, we can use memoization, a technique that stores previously computed results. Correct, this is memoization. Instead of recalculating the shortest subsequence for the same inputs multiple times, we can store results in a map, which is a DP table, where the key is the combination of the remaining portions of string str1 and str2. and when we encounter the same state again, so they are mapping. In map they use the entire string at the first place. Okay, that is why this is a very bad thing, because they are kind of, yes, exploiting the space to its fullest. We can retrieve the stored result instantly, avoiding redundant calculations. More specifically, if both S1 and S2 are empty, there is nothing left to process. We return an empty string. If one string is empty, other will return, right? When the first character of both string match, we include that character in the result and recursively compute the shortest supersequence for the remaining strings. So when the first character of both strings match, we include it in the, yeah, that is going to be the answer, right? If the first character matches, that's very much obvious, right? I'll show you what they want to say in this part here. If there is some string like C, A, B, D, E, F, and we have C, D, E, G, H. Forget about everything. When we start to create the master string, so it must start with C, because yeah, it must start with C. This is the starting point of both of these things. Now the problem reduces to answer of this part and answer of this part. These are now independent problems. This is the part problem which we have to solve. Right? Now there are two cases, right? Now it is not same. So what will happen here? From this there will be two branches. First branch and second branch. First branch when we took A, we took C, make CA. Oh, I think my pencil charge is over. Let me charge it. Till then I'll walk through the solution. So let me tell you how. Just a second, guys. Hmm. So there are two cases here. We take A and we take D. Because when we are constructing the superstring, right? So it will be either CA or CD. Makes sense, right? When we are combining these things. So what they have done is this. However, if the first characters are different, we have two choices. Include first character of S1 and recursively compute the shortest supersequence. Yes, and recursively, if we include A guy, then the problem boils down to this part, the one which I'm circling, right? From here till end and from D till end. So that's what they will do. And where will they memorize it? Basically, they think that this two strings are unique strings, right? Whatever the answer comes out of it, they'll memorize it, and they will just append this C to the first, at the front. That's what is happening in the code. Let me show you how it is happening. Okay, so here is a helper function. It is caching these str1 and str2. So how are they creating it? str1, str2, unordered map, the memoized string, is an unordered map, which is good because we have to just access it index wise. If it is computed, how do we know it's computed? If it's there in the table, then you return it. This is basically the memoization part. If both empty, this is the base case, then we return this. If one of them is empty, we return str. And then what we do is basically that case where we create substrings, and we here basically this will remove the first character from the beginning, and this way we proceed. This is a very good solution, but this is entirely time complexity is n into m n plus m. Why? Because there are, in the worst case, we have n into m unique subproblems, such as each problem is defined by a unique combination of suffixes s1 and s2. Okay, so they say that, yeah, since s1 and s2 are contiguous paths, it is n plus m, n into m, and then for this is cool, but the space complexity here is for that hash map. It won't be able to sustain that because this goes 10 to the power 9, dominated by memorized result storage. Correct. Then we have bottom up DP approach, caching the results instead of using recursion memorization. We can transition to bottom up. Okay, where we iteratively build the solution using a table. I'm really new to this. This will help us to compute the shortest common subsequence without redundant recursive calls. Without redundant recursive calls, we can build this. To explore more dynamic programming, check out the. So define a conceptual 2D table where stores the shortest common supersequence of prefixes. A DP of row call stores the shortest common supersequence of prefixes. Yeah, this is the DP table basically. Cool. The row and column. However, maintaining the entire 2D table, we can prioritize two rows at a time. Previous row which represents the previous row in the table. I literally have to read this and then I'll be able to get this. Guys, I have half an hour left. Obviously, I won't be coding it, but let's read it. So there's a table where row stores the shortest common supersequence of the prefixes. str1, it will go from 0 to row. Okay, it's like m and n from 0 till ending, something like, right? We can optimize space uses by keeping only two rows at a time, previous row and current row. Previous row means that we have, yeah, we have to compute them, right? So since each data entry in table depends on the values from the current and previous rows, the optimization is significantly, yeah, basically what happens when you create a table, right? The answer of uh, these two folks, it is like this. I'll just tell you how it is. It is literally like this. Charge my phone. 7 बजे निकल रहा हूँ at any cost. So guys, I think I cannot do the next part. Basically, I cannot solve this problem because of the time shortage. What I'll do is basically I'll create another video solving this problem, understanding this and solving the problem. But since I have spent time and finally I am reading the solution only, I'll copy the solution for the time being and paste it. This is flop now. I guess I have to close it anyway. can say here, for the time being, I invested 3 to 4 hours in this problem. Could not solve it for my timed efforts. This deserves a streak. The learning is still incomplete. I am short on time today, so I will solve this. Since I have no issues with this problem, I have to note it, guys. I have to note it somewhere so that we all get reminded of. I get reminded of solving this problem very seriously. And from today's onward, I won't upload my live session videos to main channel. It will have some very good discussion problems only. Yes, that I can do. So what I can do is basically submit this. Very sorry, guys. What I'm doing, I should not be sorry actually, because this is not easy when I do this job and stuff. At least I give an honest attempt to this problem. That's my win for the today's day. Very sorry, guys. What I'm doing, I should not be sorry actually. Right, so this is really crazy, man, to us. Okay, guys, bye for today. See you in the next one. Bye.